to math part. So first topic of class 9 ICSE, rational and irrational numbers. Today we are going to solve the last exercise, exercise 1D. If you are new to the channel, please subscribe. Here we go, children, and we start with the first question. Simplify root 18 upon 5 root 18 plus 3 root 72 minus 2 root 162. So when we look at this, you can find the factor or split this 72, you will find 18 in it. So here we go. So we have root 18 in the numerator. Denominator, we have 5 root 18. This 72 is 18 times 4 and 162 is 18 times 9. Okay. So when we look at this, now we know the square root of 4 is 2. So when it comes out, this is going to be 3 into 2. Okay. And this square root of 9 is 3. So when it is coming out, it is going to be 2 multiplied by 3. So we rewrite this as root 18 upon, we have 5 root 18. Now this root 4 is 2 and 2 times 3, it is going to be plus 6 root 18. And this is going to be root 9 is 3. So 3 times 2, it is going to be minus 6 root 18. So this 6 root 18 minus 6 root 18 got cancelled. So we have a root 18 upon 5 root 18. This root 18 and root 18 got cancelled. So our final answer is 1 upon 5. So when we simplify this, we get it as 1 upon 5. We move on to the next question. So it is root x square plus y square minus y upon x minus root x square minus y square divided by root x square minus y square plus x upon root x square plus y square plus y. Looks difficult, but it is very easy. So we have already learned about fractions. So we keep the first fraction as it is. So it is root x square plus y square minus y upon, this was x minus root x square minus y square. This division, we make it as multiplication and we take the multiplicative inverse of this. When we take the multiplicative inverse of this, this goes up, it becomes root of x square plus y square plus y. So reciprocal of this is going to be like reciprocal of 1 by 2 is 2 by 1. So that is what we do over here. Now when we take this in down, so we will write it as x plus root x square minus y square, thinking of this is x minus root x square minus y square. So you get an identity over here. So when I rearrange this, I get x plus root x square minus y square. Now observe this carefully. Which identity you are able to see over here? Just observe very carefully. Look at this numerator and denominator, children. When you look at this numerator and denominator, you find this. This is a minus b into a plus b. Again, this is a minus b into a plus b. So this is here. This is your a. This is going to be your b. So we have a minus b into a plus b is equal to a square minus b square. So we write this as a square. So a square is root x square plus y square and the square of that, and minus b square. Your b is y, so minus y square. Denominator, we have a square is going to be your x square. X and x is in the place of a, minus b square, which is root of x square minus y square and then the square of that. Okay. So when this comes out of the square, this becomes x square plus y square and this is minus y square here. In the denominator, you have this is x square, and when this comes out of the root, this is going to be x square minus y square. So this is going to be minus x square and minus of minus, this is going to be plus y square. Now simplify this further. On simplifying, you can see that y square minus y square got cancelled. Here x square minus x square got cancelled. So what is left here? We are just left with x square upon y square. So the simplified form of this is x square upon y square. Okay, if not understood, rewind and watch again, children. We have to solve each exercise, so we move on. Evaluate correct to one decimal place the expression 5 upon root 20 minus root 10 if root 5 is given 2.2 and root 10 is given as 3.2. Okay, now let us simplify here. So we have 5 upon Now root 20 can be written as 4 times 5 and minus root 10. Now we know that square root of 4 is 2. So this becomes 5 upon 2 root 5 minus root 10. Let us substitute the value. The root 5 value is given as 2.2. So this is 2 multiplied by 2.2 minus root 10 value is given 3.2. So which we get as 5. 2 multiplied by 2.2 is 2 to the 4. 2 to the 4 is 4.4 minus 3.2. So 5 minus 4.4 minus 3.2 is 5 upon 1.2. So let us simplify this further. Multiply here by 10, multiply by 10. So you get 50 upon 12. And 50 upon 12, when you solve, you are getting 12, 4 the 48. Okay, 4.166, right? So on rounding it to one decimal place, since they have asked to round up to one decimal place, we get it as 4.2. Okay, let us move on to the next question. If x is equal to root 3 minus root 2, find the value of x plus 1 upon x. And you have 4 sub questions over here. So on this page, let us solve this x plus 1 upon x and x square plus 1 upon x square. So x plus 1 upon x. So let us write the value. If I have to find the first one, x plus 1 upon x. So let us write the value of x, which is root 3 minus root 2 plus 1 upon x is going to be 1 upon root 3 minus root 2. Let us rationalize this part. So when we rationalize this part, the rationalizing factor is root 3 plus root 2 upon root 3 plus root 2. Let us simplify it further. So you get this as root 3 minus root 2 and plus this is root 3 plus root 2 upon, this is again a minus b into a plus b is going to be a square. Root 3 square is going to be 3 and root 2 square is going to be 2. So 3 minus 2, which is 1, which we get as root 3 minus root 2 plus root 3 plus root 2. So where this root 2 and root 2 got cancelled, we got this value as 2 root 3. So this is the value of x plus 1 upon x. So you get x plus 1 upon x is equal to 2 root 3. Now you have to find the value of x square plus 1 upon x square. So what we do now here, we square this, start squaring x plus 1 upon x. So on squaring x plus 1 upon x, what we get the identity, recall the identity a plus 1 upon a the whole square. So x plus 1 upon x, the whole square is going to be x square plus 1 upon x square plus 2. We are targeting x square plus 1 upon x square. So we get x square plus 1 upon x square is equal to this plus 2 shifts here becomes minus. So x plus 1 upon x, the whole square minus 2. Let us put the value of x plus 1 upon x, which we have got 2 root 3. So 2 root 3 square minus 2. Now 2 root 3 square, 2 square is 4, root 3 square is 3. So 4 3s are 12 and 12 minus 2, you get this value as 10. Got it? So you have got the value of x plus 1 upon x as 2 root 3 and x square plus 1 upon x square as 10. Now further we have to solve more. So we have to find now x cube plus 1 upon x cube. To find x cube plus 1 upon x cube, now what is the identity we have? A plus b the whole cube is equal to a cube plus b cube plus 3ab in bracket a plus b, right? So if I have to find a cube plus b cube, so this becomes x cube plus 1 upon x cube is equal to x plus 1 upon x the whole cube. And if this goes over this side, it becomes minus 3ab. Now 3ab means 3 into 1 upon x into x into 1 upon x. So which is going to be 3 again. So minus 3 in bracket x plus 1 upon x. Let us substitute the value x plus 1 upon x was 2 root 3. So 2 root 3 cube minus 3 multiplied by 2 root 3. So 2 root 3 cube is going to be 2 cube is 8 and root 3 cube is going to be 3 root 3. So root 3, it is root 3 into root 3 into root 3 when you do. So root 3 into root 3 is going to be 3. So this becomes 8 into 3 root 3, which is 24 root 3. Okay, this part. Now this is minus 3 to the 6 root 3. Minus 6 root 3 and minus 6 root 3. So 24 minus 6, we get this as 18 root 3. Got it? So we have solved this now, x cube plus 1 upon x cube. Let us solve it further. The next part of this question. So we had got the value of x cube plus 1 upon x cube as 18 root 3, remember. Now let us put the values over here. So x cube plus 1 upon x cube, we have got 18 root 3 minus 3 x square plus 1 upon x square, the value we had got was 10, and x plus 1 upon x, the value was 2 root 3. So let us add this all. So we have 18 root 3 plus 2 root 3 is 20 root 3 minus 3 times 10 is 30. So 10 can be taken common. Taking 10 common, we have 10 2s are 20. So 2 root 3 minus, when we take from 30, 10 has gone, it is left with 3. So this is our final answer for fourth part of this question. Got it? Let's move on to the next question. State true or false. Negative of an irrational number is irrational. Yes. So let us take any irrational number. Let us take root 2. Okay. So negative of root 2 is minus root 2. So this is irrational. Correct? If I take root 3, the negative of root 3 is minus root 3. This is also irrational. So therefore, this is a true statement. Okay. The next it says the product of a non-zero rational number and an irrational number is a rational number. So non-zero rational number, let us take non-zero rational number as 2, and an irrational number, let us take root 2. So 2 into root 2, I get 2 root 2, and 2 root 2. So what we obtain here, 2 root 2, it is an irrational number. Okay. So this is a false statement. Okay. Let us take one more example. Let us take 5. 5 multiplied by root 3, we get 5 root 3, and 5 root 3 is an irrational number. So this statement is a false statement. Let's move on to question number 8. So we have here 4 minus root 5 upon 4 plus root 5. We have to prove this all LHS is equal to RHS. So here we will rationalize each part of this. So let me see if I am able to write a small handwriting here. So 4 minus root 5 upon 4 plus root 5. The rationalizing factor is 4 minus root 5 upon 4 minus root 5 plus we do this 2 upon 5 plus root 3. So rationalizing factor is here 5 minus root 3 upon 5 minus root 3 plus again 4 plus root 5 upon 4 minus root 5. Rationalizing factor of this is 4 plus root 5 upon 4 plus root 5 and plus 2 upon 5 minus root 3. The rationalizing factor is 5 plus root 3 upon 5 plus root 3, right? So we now rationalize it. Let us simplify this, each of these further. And on simplifying this, this you get as a minus b the whole cube. Several questions we have solved like this. Now this you should be able to do in easy way. So a 4 minus 5 the whole square is going to be 4 square, which is 16 minus 2ab, that is 2 into 4 into root 5 plus b square, that is root 5 square, okay, upon a square minus b square, that is 4 square minus root 5 square. Okay. So this is going to be, then I rationalize this. I am getting this as 16 and this is root 5 square is 5. So 16 plus 5, I'll get 21 minus 4 to the 8 root 5 upon 4 square is 16 and 16 minus 5 is going to be 11. So same way if I do the next part, this is going to be 2 into 5 is going to be 10. So let us keep like that, only 2 in bracket 5 minus root 3 upon, we have a square minus b square, that is 5 square minus root 3 square. So this is going to be 2 in bracket 5 minus root 3 upon 5 square is 25 and root 3 square is 3. So 25 minus 3 plus, let us a plus b the whole square. So this is going to be 16 plus 8 root 5 plus root 5 square is 5 upon 4 square is going to be 16 minus 5 square is going to be 5. So this is going to be 21 plus 8 root, sorry, this is plus over here, 21 plus 8 root 5 upon 11. When I simplify this part, I'm getting this as plus 2 in bracket 5 plus root 3 upon 5 square minus root 3 square, which we get it as plus again here 2 in bracket 5 plus root 3 upon 25 minus 3, which is going to be 22. So let us write this. We get 21 minus 8 root 5 upon 11 plus 2 in bracket 5 minus root 3 upon 25 minus 3 is 22 plus 21 plus 8 root 5 upon 11 plus 2 in bracket 5 plus root 3 upon 22. So the LCM here is going to be 22. So if the LCM is going to be 22, children, I'm going to simplify this only. So here I'll have to multiply by 2. This I'll have to multiply by 2 over here. Okay. And here again, I'll have to multiply by 2. Right. So that the denominator is going to be 22. So when I do this, I find this as 21 into 2. I'm getting at 42 minus 16 root 5. Okay. Plus 2 5s are 10 minus 2 root 3 plus 2 into 21 is 42 plus 8 root 5 plus 2 5s are 10 plus root 3. This all divided by 22. This all divided by 22. Got it? So here when we look at the numerator, what all we are able to simplify? Okay, changing the color. Okay, so we get this 8 root 5. This is going to be 2 8 the 16 root 5. So this plus 16 root 5 minus 16 root 5 got cancelled. Okay. This is 2 root 3 and then this is going to be 2 root 3 again. This 2 root 3 minus 2 root 3 got cancelled. Right. Now this is 42 plus 10 plus 42 plus 10, that is 84 plus 20, we get 104. 104 upon 22, divide by 2 both, we get this as 52 upon 11. 104 divided by 2, we get 52. 22 divided by 2, we get 11. This is how we have simplified this as 52 upon 11, and we have proved this, that LHS is equal to RHS. Got it? It's easy. Just that you have to rationalize each and every term given in this. Let's move on to equal to 52. You have to show that x cube plus 1 upon x cube is equal to 52 if x is equal to 2 plus root 3. If let's find x plus 1 upon x over here. So we put the value, x value is 2 plus root 3 plus 1 upon x value is 1 upon 2 plus root 3. Let us rationalize this part. So rationalizing factor is 2 minus root 3 upon 2 minus root 3. On simplifying this, we get this as 2 plus root 3. Here 1 into 2 minus root 3 is plus 2 minus root 3. And the denominator here, a plus b into a minus b is a square minus b square. So 2 square is going to be 4 and root 3 square is going to be 3. So finally we get this as 2 plus root 3 plus 2 minus root 3 upon 1. So root 3 and root 3 got cancelled. We got the value of x plus 1 upon x as 4. Okay, now let us find the value of x cube plus 1 upon x cube. So x cube plus 1 upon x cube, we know the identity, it is x plus 1 upon x the whole cube minus 3 in bracket x plus 1 upon x. Okay, now x value is 4, so 4 cube minus 3 multiplied by 4. 4 cube is 64 and 3 multiplied by 4 is 12. 64 minus 12, we get it as 52. Thus, we have proved that x cube plus 1 upon x cube is equal to 52. Got it? Let's move on to the next question. The second part of this, 9th question, we have x square. You have to show that x square plus 1 upon x square is equal to 34 if x is equal to 3 plus 2 root 2. Now, x square plus 1 upon x square you will get when you will square x plus 1 upon x. So, let us first find x plus 1 upon x. Put the value of x, it is 3 plus 2 root 2 plus 1 upon x is 1 upon 3 plus 2 root 2. Let us again rationalize this part. Rationalizing factor is 3 minus 2 root 2 upon 3 minus 2 root 2. Okay, so we simplified further. So 3 plus 2 root 3 remains as it is. 1 multiplied by 3 minus root 2 is plus 3 minus 2 root 2. And denominator of this is going to be again 3 square minus 2 root 2 square. Minus 2 root 2 square. Okay, I'll write this down here. 3 square minus 2 root 2 square. Okay. Now 2 root 2 square is 8. 2 square is 4 and root 2 square is 2. So 4 2s are 8 and 3 square is 9. So denominator we are going to get 1. Let me write it here neatly. So you get 3 plus 2 root 3 plus 3 minus 2 root 3 upon 3 square was 9 and 2 root 2 square was 8. So this is 9 minus 8 is 1. So finally, we are getting simply 3 plus 2 root 3 plus 3 minus 2 root 3, where 2 root 3 minus 2 root 3 got cancelled and 3 plus 3 we got the value as 6. Now we got the value of x plus 1 upon x as 6. Let us now do x plus 1 upon x the whole square. So x plus 1 upon x the whole square is 1 upon is x square plus 1 upon x square plus 2, right? So we want to find the value of x square plus 1 upon x square. This plus 2 will go here, it will become minus. So you have x square plus 1 upon x square is equal to x plus 1 upon x the whole square. And this 2 shifts over here, it becomes minus 2. Put the values, x plus 1 upon x, the value you have got 6. Now 6 square minus 2. 6 square is 36 and 36 minus 2 you get this as 34. Hence we have proved x square plus 1 upon x square is equal to 34. Got it? Let's move on to the next question. Show that 3 root 2 minus 2 root 3 upon 3 root 2 plus 2 root 3 plus 2 root 3 upon 3 root 2 upon root 3 minus root 2 is equal to 11. Again, same thing, children. You'll have to rationalize it separately. So we write here 3 root 2 minus 2 root 3 upon 3 root 2 plus 2 root 3. Rationalizing factor is going to be 3 root 2 minus 2 root 3 upon 3 root 2 minus 2 root 3. Put the brackets for this. So you understand that in the numerator you have a minus b the whole square. The denominator you have a plus b into a minus b plus 2 root 3 upon root 3 minus root 2. The rationalizing factor here is going to be root 3 plus root 2 upon root 3 plus root 2. Now 3 a minus b the whole square. So we get 3 root 2 square, that is a square, minus 2ab, minus 2 into 3 root 2 into 2 root 3 plus b square, that is 2 root 3 square. Denominator we have a plus b into a minus b, which becomes a square 3 root 2 square minus 2 root 3 square. Again here we have 2 root 3 in bracket, 2 root 3 in bracket, root 3 plus root 2. We'll simplify it further. Denominator we have a minus b into a plus, that is root 3 square minus root 2 square. So 3 root 2 square, 3 square is 9, root 2 square is 2. 9 2s are 18 minus 2 3s are 6, 6 2s are 12. 2 3s are 6, 6 2s are 12. Root 3 into root 3 is root 6. So 12 root 6. Again 2 square is 4, root 3 square is 3. 4 3s are, this is 12. So plus 12 upon 3 root 2 square is going to be, just now we have done here, it is 18. And 2 root 3 square we have done, it is 12 minus 12 plus root 3 into root 3 is 3. So 2 root 3 into 3 is going to be 2 3s are 6 plus 2 root 3 into root 2 is going to be 2 root 6 upon root 3 square is going to be 3 and root 2 square is going to be 2. So 3 minus 2. Let us simplify it further. So we get 18 plus 12 is going to be 30. 18 plus 12 is 30 minus 12 root 6 upon 18 minus 12 is 18 minus 12 you get as 6 plus 6 plus 2 root 6 upon 3 minus 2 is 1. So if I simplify from here, if you take common 30 and 12, the HCF is going to be 6. If I take 6 common from here, so from this part we take 6 common, we are left with 6 5s are 30 minus 6 2s are 12, root 6 upon 6 plus 6 plus 2 root 6. Okay, now this 6 and 6 got cancelled, and then you are left with 5 minus 2 root. So sorry, this was root 6. Okay, so this is 5 minus, let me solve it over here further. So you have 5 minus 2 root 6 plus 6 plus 2 root 6. This root 6 and root 6 got cancelled, and 5 plus 6 you get is as 11. And this is how we have proved that this is equal to 11. Got it? Let's move on to the next question. Show that x square is equal to 6. Show that x is irrational. So if x square is equal to 6, x is equal to root 6, and root 6 is an irrational number. So this is how you can say that x is an irrational number. Now the next part of this is x square is equal to 0.0009. So if I have to find x, then it is going to be root of 0.0009, and if I find the root, it is root of 9 upon 1000, and if I find the root of 9 upon 1000, this is going to be root of 9 is going to be 3, and 1000 we have 10 into 10 into 10. So when you root this 10 into 10 comes out, this becomes 3 upon 10 root 10. So this is an irrational number. So thus we have proved that x is an irrational number. The next part of this is x square is equal to root 27. So you get x is equal to root of 27. So root of 27 is 3 into 3 into 3 under the root. So this 3 comes out, we get 3 root 3, and this is an irrational number. Got it? We have proved that x is irrational in all the 3 cases. Question number 11. Show that x is rational if x square is equal to 16. Now, if x square is equal to 16, x is equal to plus or minus root 16, which we get it as plus or minus 4, and it is a rational number. So, plus 4 and minus 4 both are rational numbers. The next, x square is equal to 0.00004. So, you get x is equal to root of 0.0004, which is equal to root of 4 upon, you will get 4 zeros in front of that. So square root of this is 2 upon square root of 10,000 is 100. So when you simplify, you get 1 upon 50. And yes, it is a rational number. 1 upon 50 is a rational number. The next, x square is equal to 1 7 upon 9. So 1 7 upon 9, 9 ones are 9, 9 plus 7, we have 16 upon 9. So x is equal to square root of 16 upon 9. So which is plus or minus, square root of 16 is 4, square root of 9 is 3, and this is again a rational number. Okay, so thus we have proved that these are rational. So the last question of this exercise, using the following figure, show that BD is equal to root x. So look at this figure. We have AC is equal to, if I write AC is equal to AB plus BC. So AB is x and BC is 1. So you get x plus 1. So if I have to find OC, since O is the center of this semicircle, we get OC is equal to AC upon 2, which is x plus 1 upon 2. Right? We got OC. So same way, you will also get OD, because they are the radii of the same circle. So OC is equal to OD. So OD is also x plus 1 upon 2. Right? Now, since we have to find BD now, let us find OB. So OB is equal to, if I have to find OB, this will be OC minus BC. So it will be OC minus BC. So OC is x plus 1 upon 2 and BC is 1. So which when we simplify, we get x plus 1 minus, if I take LCM, which is going to be 2 upon 2. So which is equal to x plus 1 minus 2 is minus 1. So x minus 1 upon 2. So now we found OB. Let us use Pythagoras theorem here. So by using Pythagoras theorem, we have OD square is equal to OB square plus BD square. So if you have to target BD square, so you get BD square is equal to OD square minus OB square, right? So let us substitute the value here now. OD square is, we had calculated OD square as x plus 1 upon 2, the whole square, minus OB, we have calculated x minus 1 upon 2, the whole square. So we have an identity here now. A square minus b square is a plus b into a minus b. So let us put here a plus b, that is x plus 1 upon 2 plus x minus 1 upon 2. Now when we are doing minus sign, again a minus b, x plus 1 upon 2 minus x, this minus 1 is going to be plus 1, plus 1 upon 2. So denominator is same, so we add the numerators here. So we get x plus 1 plus x minus 1 upon 2 into x plus 1 minus x plus 1 upon 2. So on simplifying this, you get x minus x got cancelled. Here 1 and minus 1 got cancelled. So we are getting here 2x upon 2. So which 2 and 2 got cancelled. And 1 plus 1, we are getting 2 upon 2, which is going to get 1. So this is how we get here BD square as x. Okay. Now if BD square is equal to x, then we can write BD is equal to root of x. And thus we have proved that BD is equal to root x. Understood, children? If you like the video, please share with your friends. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.